So for this question here, for section 3.6 on the MyOpen Math, they're telling me here, let me get a pointer going. They're telling me that they want me to factor this fifth degree polynomial. They're also telling me that 2i is a 0. And they want me to write it all in factored form with linear factors. So what I've got going here is, since I know, and I didn't show this, I've got all this work done on another paper, but some of it I didn't write down that'll add here. And I'll make that paper available somehow. Okay, so what I've got, since I know that x equals 2i is a 0, and this is a complex 0, complex zeros occur in conjugate pairs. So that also tells me that x equals negative 2i is a 0. That takes care of 2 of the 5 zeros. So I don't want to deal with i's and imaginary numbers. So what I'm going to do is I'm going to square both sides of this, and I'm only going to work with one of them. Well, maybe I'll work with both of them in case you don't know. How do I change the color? Oh, here we go. So I'm going to square this side. I'll come over here and square this side too, just so you know you never have to do that again. So that leaves me x squared. And then when I square 2, I get 4. And when I square I get negative 1. Look what happens here when I do the conjugate, which they didn't tell me was a 0. So I'm going to get x squared. If I square, now this is all multiplication, so I don't have to worry about foiling or anything. What's a negative number squared is positive. 2 squared is 4. I squared is a negative 1. Notice how I get exactly the same answer. So I only have to worry about one of them to write this out. So then that's going to give me x squared plus 4 equals 0. Now I want to get rid of this. I want to break down this fifth degree equation because I don't know how that factors. But I do know that this is a 0. So what I did is, let me come to a pointer. And let's see here. Oh, what's this? I've got all these files open. Here, just a minute. I'm going to pause this video so you don't have to wait for me looking for that window. Okay, so because I'm dividing, I want to divide that polynomial by a quadratic. I can't use synthetic division. Well, I don't want to use synthetic division for it because that gets messy. So I just chose to use long division. And I won't walk you all the way through my math here, but you can certainly take a look at it. And so that's the quotient. Notice I got 0. Notice I got 0 for remainder. So that tells me that tells me x squared plus 4 is a factor. Of course, we knew it was because we knew those were zeros. So that's what's left. So then if I write these as factors, I've got this. Now, none of those are linear, so I need to do some more work. But I know how this one factors. I know how the x squared plus 4 factors, because that's at x plus 2i, x minus 2i. How does this one factor? So I got to try to factor that cubic. And I could do that p over q trick and all that. But as you've heard me say before, this is the 2020 today. And so I just graphed the cubic part, and I'm not too sure about these zeros here, but that positive 1 is definitely a 0. So what I did is I went back, and now because x equals 1 is a linear factor, I can use synthetic division. Let's see, where did I do this? Right here, no. Oh, there it is. So then I chose to say I divided, do synthetic division to divide 1 in, and that left me with 3x squared plus 5x plus 2. And I could try something else, but I can factor pretty well. So I factored this quadratic into this, which factored nicely, and then that gave me the 2 other zeros at x equals negative 2/3 and x equals 1. And, just out of curiosity, I did go back and look on my calculator. I won't show you how to do that. And yeah, those are zeros. So I got my 4 zeros. I've got x equals plus or minus 2i. I've got x equals 1, and I've got these factors. So then to write them as a linear factor, write these things as linear factor, I know it's got to be x minus 2i, x plus 2i, because x, if you have x equals, right, let's make sure you understand that. If I have x equals positive 2i, if I subtract 2i from both sides, I get x minus 2i equals 0. And then same, if I add negative 2i or add 2i to both sides, I'm going to get x plus 2i. That's my other complex 0. Bring the 1 over, so that's x minus 1. Because my open math, and frankly, just writing something as x, if I were to write this, let's see, if I were to write this x plus 2/3, while that works, it's not really neat. So what I did is, so what I do to solve this, some of you have asked, I'm going to multiply both sides by 3, so that gives me 3x equals negative 2, then I'm going to add 2, and so that's where I got that factor from. And then the other one, the x plus 1, and then of course I know you probably noticed that I did get this correct on my open math. Let's see, where are we? Yeah, there it is. So I did get that correct, and I entered in. Make sure you enter in the equation. I when I first did this, I forgot the p of x equals. Sometimes when my open math tells you p of x equals on the outside, that's not part of the answer. So you don't have to type that. Here they do. Okay, so hopefully this helps you write these polynomials in factored form, and maybe help you on that quiz question that's coming up in week 5. Okay, I'm going to stop this video and get it uploaded.